In 1969, America tested a nuclear rocket engine that could reach Mars in 4 months. It worked. They fired it 28 times. Then they canceled it and buried the blueprints. In 1964, America built a nuclear cruise missile so powerful it could fly for weeks without refueling. It worked. They ran it at full power for 5 minutes. Then they dismantled it and classified the footage. In 1963, America designed a nuclear pulse drive that could carry 10,000 tons to Jupiter. The physics checked out. The Air Force funded it. Then they made it illegal. This isn't a video about rockets that failed. This is a video about rockets that worked and got killed anyway. 4 programs, 4 different decades, 4 different excuses. But the same result every single time. Humanity stays trapped in low Earth orbit. This is the classified history of nuclear propulsion. And by the end, you'll understand exactly why we're not on Mars right now, and whose fault it actually is. While NASA is still figuring out how to squeeze a man into a tin can, a physicist named Freeman Dyson is sketching something that looks like it belongs in a fever dream. A spaceship the size of a battleship, propelled by atomic bombs. Not metaphorically, literally. Atomic bombs detonating behind the ship, one after another, pushing it faster and faster into the void. They called it Project Orion. Here's how it worked. You take a spacecraft with a massive steel pusher plate at the bottom. Think of it like a nuclear-hardened shield. Behind the ship, you eject shaped nuclear charges. Small ones at first, then bigger as you pick up speed. Each explosion slams into that pusher plate and shoves the ship forward. It's not subtle. It's not elegant. It's basically using nuclear weapons as a propulsion system. But here's the thing about crude solutions. Sometimes they work spectacularly well. The thrust-to-weight ratio of nuclear pulse propulsion was unlike anything chemical rockets could touch. Not twice as good, not 5 times as good. We're talking orders of magnitude better. And this wasn't some fringe theory scribbled on a napkin by a crackpot. General Atomics ran the numbers. They did the engineering studies. The United States Air Force wrote checks, real money, millions of dollars, to figure out if this thing could actually fly. The conclusion was staggering. A single Orion ship could deliver 4,000 tons of payload to Mars. Let that sink in for a second. 4,000 tons to Mars. For comparison, the entire Apollo program, all those Saturn V rockets, all those missions, all those years of effort, put about 50 tons on the moon. Orion could do that in one trip, and it wouldn't have to stop there. The same ship could continue on to Jupiter, to Saturn, to the edge of the solar system and beyond. This wasn't science fiction. The physics were sound, the engineering was plausible, and they proved it worked. They built scale models and tested them with conventional explosives in the Nevada desert. The little prototypes flew. They actually flew. The pusher plate absorbed the blast exactly as predicted. The shock absorbers dampened the acceleration just like the math said they would. Everything checked out. The Air Force was so convinced, they classified Orion as a serious weapons delivery platform. You could put nuclear warheads in orbit, you could establish permanent military bases on the moon, you could project American power anywhere in the solar system. By 1963, Project Orion wasn't a dream anymore. It was a plan, and then it died, August 5, 1963. Orion didn't die because of an engineering failure. It didn't die because someone found a flaw in the physics. It didn't even die because of a budget cut. It died because of a signature. On that day, President Kennedy and Premier Khrushchev signed the Partial Test Ban Treaty, an agreement between the United States, the Soviet Union, and the United Kingdom to stop testing nuclear weapons in the atmosphere, underwater, and in outer space. The goal was noble. The arms race was spiraling out of control. Both sides were detonating bombs at an insane pace. Hundreds of tests, mushroom clouds blooming across the Pacific, across Siberia, across Nevada. Radioactive fallout was showing up in milk, in wheat, in children's bones. Something had to give. The treaty was designed to slow the madness, to stop the fallout, to give humanity a chance to step back from the brink. And it worked. For that purpose, it worked beautifully. But there was a catch. To develop Orion, you had to test it. And to test it, you had to detonate nuclear devices in space, which was now illegal. The treaty didn't just ban weapons tests, it banned any nuclear explosion outside of underground containment. That meant no atmospheric tests, no underwater tests, and no tests in outer space, even for peaceful purposes. Orion wasn't canceled, it was made illegal. You couldn't even run an experiment without violating international law. The same signature that might have saved civilization from nuclear war also slammed the door on humanity's best chance to reach the stars. The project limped along for a few more years on paper, but everyone knew it was over. By 1965, the funding dried up completely. The engineers scattered. The blueprints went into filing cabinets, and there they stayed. Here's the part that makes this tragic instead of just frustrating. Freeman Dyson, the physicist who designed Orion, the man who dreamed of Mars colonies and Jupiter expeditions, the visionary who saw humanity spreading across the solar system, supported the treaty. He voted to kill his own project. Think about that. The guy who spent years of his life working on Orion, who believed in it more than anyone, who knew exactly what we were giving up. He looked at the bigger picture and said yes. Sign it, ban the tests, end my dream. His reasoning was straightforward, even if it was agonizing. The arms race was existential. Both superpowers had enough weapons to end civilization several times over, and they were building more every day. The fallout from atmospheric testing was poisoning the planet, not metaphorically, literally poisoning it, with strontium-90 settling into the food chain and cesium-137 contaminating entire regions. Orion, as magnificent as it was, wasn't worth nuclear war. It wasn't worth a generation of children growing up with radioactive isotopes in their bones. Dyson made a choice. He traded his ticket to Mars for the survival of civilization. Whether that was the right call? Honestly, that's above my pay grade. Reasonable people can disagree. But here's what matters for our story. Orion didn't fail. It was sacrificed. The technology worked. The physics were sound. The engineering was validated. And we killed it anyway. Not because it couldn't take us to the stars, but because the world wasn't ready to let it try. But while Orion died because of international law, the next nuclear program was killed for a very different reason. It wasn't too dangerous for the world. It was too dangerous for anyone to use. If Project Orion was the dream, Project Pluto was the nightmare. And unlike Orion, this one was never about exploration. This was about annihilation, pure, calculated, horrifying annihilation. They called it SLAM, Supersonic Low-Altitude Missile. Here's the concept. You take a cruise missile, but not just any cruise missile. This one is powered by a nuclear reactor, not nuclear fuel. An actual, running, unshielded nuclear reactor, serving as the engine. Air comes in the front, it passes through the reactor core. The nuclear reaction heats it to insane temperatures. The superheated air blasts out the back as thrust. No moving parts in the engine, no fuel to run out. As long as the reactor keeps running, the missile keeps flying, and the reactor could run for weeks. Now imagine what you could do with a cruise missile that never runs out of fuel. SLAM was designed to fly at Mach 3, 3 times the speed of sound, at an altitude of 500 feet, treetop level, below radar coverage, too fast to intercept. It would streak across the Soviet Union, dropping hydrogen bombs on targets along the way. Not one bomb. Multiple warheads, released one by one, city after city, base after base. But the bombs weren't even the worst part. Just flying SLAM was an act of war. Think about what's happening physically. At Mach 3 and 500 feet altitude, the sonic boom alone could kill people on the ground. The shockwave from something that size, moving that fast, that close to the surface, would collapse buildings and rupture organs. But it gets worse. The reactor was unshielded. There was no way to shield it. The weight would have made the missile unflyable. So, as SLAM flew, it was spewing radioactive exhaust directly into the atmosphere. Fission fragments. Neutron radiation, a plume of fallout trailing behind it like the world's most poisonous contrail. Every mile SLAM flew left a path of radioactive contamination. It wasn't a missile. It was a flying Chernobyl with hydrogen bombs strapped to it. May 14th, 1964. Nevada desert. They were ready to test the engine. Not the full missile, just the reactor that would power it. They called it Tori IIC. The engineers gathered in the bunkers. The countdown began, and then they fired it up. It worked. The reactor blazed to life. Air screamed through the core at simulated Mach 3 conditions. The temperature readings were exactly where they needed to be. The thrust output matched the predictions. They ran it at full power for 5 minutes. No failures. No meltdowns, no unexpected problems. 5 minutes doesn't sound like much, but remember, this was a nuclear ramjet designed to fly for weeks. They weren't testing endurance. They were testing whether the concept worked at all. It did, perfectly. America had built a doomsday weapon, and it was ready to fly. The missile could have been operational within a few years. The Air Force was already planning the production line. SLAM would become part of the nuclear triad. One more way to ensure that if the Soviets ever attacked, America could rain destruction from the sky. But then something strange happened. Someone with authority actually thought about what they'd built. 7 weeks after that successful test, Defense Secretary Robert McNamara killed Project Pluto. Not because it failed. Because it worked too well. McNamara was a numbers guy, the original whiz kid, a data-driven executive who'd transformed Ford Motor Company before Kennedy brought him to the Pentagon. He looked at SLAM with the cold eye of an accountant, and he didn't like what he saw. Problem 1, you can't test it. Where exactly do you fly a radioactive cruise missile? The thing spews fallout everywhere it goes. Even a test flight over unpopulated areas would contaminate hundreds of square miles. The protests after atmospheric nuclear tests were bad enough. Imagine explaining that you'd irradiated Nevada because you wanted to see if your doomsday missile could make a turn at Mach 3. Problem 2, you can't land it. Say everything goes perfectly. The missile delivers all its warheads. The war is won. Now what? You've still got a flying nuclear reactor circling the globe. Eventually, it has to come down somewhere. Even a successful SLAM mission ends with deliberately crashing a hot reactor into the ocean. Or worse, having it fall randomly when the fuel finally runs out. Problem 3. You can't use it without ending the world. SLAM was designed to penetrate Soviet defenses and devastate their cities. But the Soviets had nuclear weapons too. The moment America launched SLAM, the Soviets would launch everything they had in retaliation. There was no scenario where SLAM provided a strategic advantage. It couldn't prevent nuclear war. It couldn't win a nuclear war. It could only make a nuclear war more horrible than it was already going to be. And finally, the biggest problem of all. ICBMs already existed. America had Minuteman missiles sitting in silos across the Midwest. Submarine-launched ballistic missiles prowling the oceans. B-52 bombers on constant alert. SLAM didn't add capability. It just added horror. McNamara made the call. Project Pluto was canceled. The test hardware was dismantled. The footage was classified. America had built the cruelest weapon in human history. And for once, someone in power looked at it and said, "No, we're not doing this." Orion was killed by a treaty. Pluto was killed by a conscience. But the next program was killed by a spreadsheet. And that's the one that still hurts. NERVA. Nuclear Engine for Rocket Vehicle Application. This wasn't a weapon. This wasn't a classified nightmare. This was NASA's ticket to Mars, and it was ready to fly. Here's how nuclear thermal propulsion works, and it's elegant in a way that SLAM never was. You have a nuclear reactor at the heart of the engine. But instead of using the reactor's heat to superheat air like a ramjet, you use it to superheat hydrogen. Liquid hydrogen flows through the reactor core. The nuclear reaction heats it to thousands of degrees. The superheated hydrogen expands explosively out the nozzle, creating thrust. Simple, clean, powerful. And here's the beautiful part. the efficiency. In rocketry, we measure efficiency with something called specific impulse, essentially how much thrust you get per pound of propellant. The higher the number, the more efficient the engine, the less fuel you need to carry, the farther you can go. Chemical rockets, the kind we still use today, top out around 450 seconds of specific impulse. NERVA hit 850, nearly double. That doesn't mean NERVA was twice as good. Because of how the math works out, that nearly doubled efficiency meant you could carry far less propellant for the same mission. Or you could carry the same propellant and go much, much farther. For deep space missions, the kind that require months of travel through the void, that efficiency advantage was everything. And NERVA wasn't theoretical. It wasn't a paper study. It wasn't a concept waiting for some future breakthrough. In 1969, the same year we landed on the moon, the NERVA XE Prime engine completed its test series. It started. It throttled up. It throttled down. It stopped. It cooled. It restarted. 28 times. No failures. The engine was flight certified. The engineers signed off. The paperwork was complete. We didn't have a concept. We didn't have a prototype. We had a working nuclear rocket engine, tested and ready for space. In 1969. 1 month after Apollo 11, 1 month after Neil Armstrong stepped onto the lunar surface, Wernher von Braun walked into the White House with the most ambitious plan in human history. Von Braun wasn't some starry-eyed dreamer. He was the man who built the Saturn V, the man who made Apollo possible. When he spoke, presidents listened, and what he proposed was breathtaking. A fleet of nuclear-powered spacecraft assembled in Earth orbit. Multiple vehicles, each one larger than anything we'd ever launched before. Departure date, November 1981. Mars landing, 1982. Return to Earth, 1983. This wasn't fantasy. Von Braun had engine test data. He had mission architectures worked out in detail. He had timelines based on real engineering, not optimistic guesses. NERVA was the keystone of the entire plan. It was the only engine efficient enough to make the mission work. Chemical rockets couldn't carry enough fuel. Ion drives were too weak. Nuclear thermal propulsion was the Goldilocks solution. Powerful enough to get there in reasonable time. Efficient enough to make the fuel requirements manageable. 13 years. We were 13 years away from boots on Mars. And we had the engine to do it. President Nixon had a problem. The Vietnam War was devouring the federal budget. The economy was struggling. The public's enthusiasm for space was fading. Once we'd beaten the Soviets to the moon, the urgency evaporated. Nixon needed to cut spending, and space was an obvious target. His Office of Management and Budget came to him with a choice. You can have a Mars program, or you can have a space shuttle. You cannot have both. The OMB made their case. The shuttle, they argued, would be reusable. It would be cheaper per launch. It would support commercial activities in low Earth orbit. It was practical. Mars was expensive. Mars was risky. Mars had no clear return on investment. What were we going to do with Mars? Plant a flag and leave, just like the moon. A truck to low Earth orbit was more sensible than a ship to another planet. The accountants had spoken. Nixon chose the shuttle. And then, to make sure no one could change their mind, they didn't just cancel NERVA. They dismantled everything. The Saturn V production line was shut down. Not paused, shut down. The tooling was destroyed. The facilities were repurposed. The engineers were scattered to other projects or laid off entirely. NERVA's funding was terminated in 1973. The test facilities were mothballed. The flight hardware was never built. The entire infrastructure that had taken us to the moon, the rockets, the engines, the factories, the expertise, was systematically demolished. By the mid-1970s, even if someone in power had changed their mind, there was nothing left to go back to. America's maximum range was now 400 miles up. Low Earth orbit, a glorified airplane altitude compared to the distances we'd been planning to travel. And here's the part that should make you angry. The OMB promised the shuttle would be cheap. It wasn't. They projected launch costs of a few $1,000,000 per flight. The actual cost ended up being over $1 billion per mission. Adjusted for inflation, the shuttle cost more per launch than the Saturn V it replaced. The entire economic argument for killing NERVA, the whole spreadsheet justification, was wrong. The reusability promised never materialized the way they claimed. The turnaround time between flights was measured in months, not days. The maintenance costs were astronomical. By the time everyone realized the truth, the nuclear program was gone. The Saturn V was gone. The moon landing capability was gone. We traded Mars for a space truck that couldn't leave the driveway. And we've been stuck there for 50 years. For 50 years, nuclear thermal propulsion sat in filing cabinets. Occasionally, someone would dust off the old NERVA reports and write a paper about what might have been. But the technology was dead. The political will was gone. The infrastructure had been destroyed. And then, in the early 2020s, something changed. DARPA, the Defense Advanced Research Projects Agency, the same organization that gave us the internet, partnered with NASA on a new program. They called it DRACO, Demonstration Rocket for Agile Cislunar Operations. The goal was to design and fly a nuclear thermal rocket in space, with an in-orbit demonstration targeted for 2026 or 2027. Officially, DRACO's mission was Agile Cislunar Operations, zipping around the Earth-Moon system for national security and future exploration. Unofficially, everyone in the nuclear propulsion community saw it as the proving ground for the engines you'd need to cut Mars trip times in half. For the first time since NERVA, the United States had funded a serious program to design and fly a nuclear thermal rocket again. The physics hadn't changed. The advantages hadn't changed. The dream was back. And if you've been paying attention to this story, you already know what happened next. Mid-2025. Before any flight hardware reached the pad, DRACO was canceled. The official reason? Return on investment. The same 4 words that killed NERVA. Different spreadsheet. Same result. Here's what happened. When DARPA first ran the numbers on DRACO, they assumed launch costs would stay high. Under those conditions, nuclear thermal propulsion was the optimal solution. 2 to 5 times the propellant efficiency of chemical rockets meant fewer launches, less orbital assembly, faster missions. The math was obvious. But then SpaceX changed the game. Starship started flying. Falcon Heavy kept getting cheaper. Launch costs were dropping faster than anyone had projected, and when DARPA reran the numbers with modern prices, the calculus shifted. The efficiency gain from nuclear thermal propulsion no longer justified what they called the massive R&D costs to develop it. On top of that, ground facilities for handling and testing a space reactor needed expensive upgrades, and regulators were already flagging the complexity of qualifying a nuclear stage for launch. In their words, the return on investment wasn't there anymore. In practice, that meant the same thing it always does in this story. A cheaper, good enough option beat the breakthrough engine before it ever left the drawing board. DRACO wasn't canceled because it didn't work. The engine design was moving forward. It was canceled because someone decided it was unnecessary. If it had flown and worked as advertised, the same technology could have underpinned faster missions to Mars in the 2030s. But DRACO itself was only a demonstrator. And demonstrators are easy to kill when the budget gets tight. Think about what just happened. In the 1970s, they said nuclear was too expensive because the shuttle would be cheaper. The shuttle wasn't cheaper. It was more expensive. But by the time anyone realized that, the nuclear program was gone. In 2025, they said nuclear was too expensive because Starship would be cheaper. Maybe Starship will be cheaper. Maybe the economics will work out this time. But that's not the point. The point is that nuclear propulsion keeps getting killed. Not because it doesn't work, but because someone always finds a good enough alternative. And good enough has kept us in low Earth orbit for half a century. Chemical rockets can reach Mars, theoretically. With enough launches, enough fuel depots, enough orbital assembly, it's possible. But possible and practical are different things. Possible and safe are different things. Possible and sustainable are different things. NERVA could have taken us to Mars in the 1980s with proven technology. DRACO could have paved the way for the 2030s. Instead, we keep choosing the cheaper option that doesn't quite get us there. 4 programs, 4 different eras, 4 different excuses. Orion. It's illegal. A treaty designed to save the world from nuclear war also outlawed the physics that could have taken us to the stars. Pluto. It's immoral. A weapon so cruel that even the Pentagon looked at it and said no. One of the few times in history that conscience trumped capability. NERVA. It's too expensive. A lie told by accountants who promised a cheap alternative that never materialized. DRACO. It's unnecessary. Another cheap alternative. Another promise that this time it will be different. But underneath all of these excuses is one constant. Nuclear propulsion works. Every single time the engines performed. The tests succeeded. The physics checked out. Orion's scale models flew. Pluto's reactor ran at full power. NERVA was flight certified. DRACO was making progress. And every single time, someone found a reason to stop. Here's what I think the real reason is. Nuclear rockets don't get canceled because they fail. They get canceled because they succeed in ways the system isn't ready for. Orion could have reached Mars in months, but the world wasn't ready to allow nuclear explosions in space. The political framework didn't exist to make it acceptable. Pluto worked perfectly, but no one was ready to authorize a weapon that horrific. The moral framework couldn't accommodate it. NERVA was flight ready, but no one was ready to fund a Mars mission. The economic framework prioritized other things. DRACO was progressing, but someone decided cheaper chemical rockets were good enough. The strategic framework didn't value the breakthrough. The technology keeps outpacing the institutions. The engineering keeps outrunning the politics. And until that changes, we stay stuck. Somewhere in a filing cabinet, probably multiple filing cabinets, in multiple facilities, across multiple agencies, there are blueprints for engines that could take us to Mars, to Jupiter, to the moons of Saturn, to the edge of the solar system. We've built them. We've tested them. We know they work. The only thing we've never been able to build is the will to use them. If you want to understand more about what we gave up when we canceled the Saturn V, I made a whole video about that. It's linked on screen now. And if you're new here, this channel covers the space programs that worked, the ones that failed, and the ones that got killed before they had a chance. Subscribe if you want to see more. I'll see you in the next one.